Hello, everyone. I'm not sure whether to say good morning, good afternoon. I think Mike, or good evening, actually, it's in Abu Dhabi. Mike mentioned jet lag. So you would have to excuse me. I'm not going to walk much. So the jet lag is hitting hard. But first, I would like to thank the Linux Foundation and Aaron for all the hospitality and for welcoming us over here. I would like to give you today a flavor about what we're doing at the Technology Innovation Institute when it comes to confidential AI. Fascinating talks before. We heard a lot about hardware-rooted security, about trusted execution environment. And I love where Mike finished, because this is what I'm going to present, where we want to move from confidential AI to be policy-based, to actually be rooted in cryptographic guarantees. So obviously, AI is embedded in every aspect of society today. We see it in healthcare, we see it in government, we see it in national defense. However, if we think about the most valuable data that we have today, it's still not at the disposition of AI. And the reason is not algorithms. The reason is not compute. The reason is actually trust. And this is where the whole topic of confidential AI, which we have been hearing about it, I'm not going to preach for it, comes into play. Everybody is excited about using AI, but when it comes to sharing data, this is where hesitance comes in. Hospitals want to protect patient information, banks want to protect financial information, governments want to protect national sovereignty, national secrets. Companies want to protect IP and they want to protect trade secrets. But really, AI's greatest potential is in connecting knowledge across organizations. And this is where confidential AI comes to make these policies, to allow data to remain protected at inference time, to allow it to remain protected at training time, and also to allow to have some sort of trust for us to know who we're interacting to, especially as AI is moving progressively into agentic platforms. And in order to address the topic of confidential AI, and as we elevate them in our work that we are doing in the Technology Innovation Institute, we look at it across three pillars. There is the data protection when we are using AI. Today, when we do a query, the minute it leaves our device, this query, more often than not, it gets exposed in plain text into some hyperscaler infrastructure, into other devices, and then we don't know where that information is being leveraged and is being used. There is data protection at the moment of training. Today, valuable information and sensitive information, it sits in silos. Because of the sensitivity and sometimes because of regulations, collaboration is almost impossible, and we're not leveraging the sum of all when it comes to intelligence being derived from this data. And then finally, as AI is moving into agents and it's progressing into those agentic platforms, more often than not today, because we don't have a uniform or a universal standard for identity, we don't know what we are interacting with, we don't know who we are interacting with, and most importantly, we don't have verifiable proofs on the actions or the decisions that those agents are making. So the way we are addressing it is through three pillars. The first one is, how do we deal with inference? And this is where we are going back to fully homomorphic encryption, which I'm sure all of you are aware of. We think about it as complementary to trusted execution environment, and this is where we are collaborating with Opaque on. When it comes to training, we look into federated learning in combination with multi-party computation, and this is where we talk about private federated learning. And then finally, authentication and trust, where we're looking into the identity of agents and the authentication and identifications of agents with large agentic ecosystems. Maybe a parenthesis is obviously this work is not coming from me, it's coming from the team, and this is where I have Dr. Victor here in the room, and you will hear more about the details of the technologies, and Dr. Shauki as well from our team, and collectively we are working on these technologies. We see this as a full stack, as an AI stack, and all of these technologies put together, they provide us with this confidential AI technologies. Data moves into models move into agents, and with this AI stack and another technology that we're working on the control plane of securities, put on top of technology of trusted execution environment and through our partnerships with Opaque, and also with the topic of the day, I would say post-quantum security, this is where we are providing this end-to-end stack across AI and the whole life cycle of AI. Allow me to go into the details of each one of them in a very quick manner, and I'm happy to discuss those in details later on. First, let's talk about inference. VEIL stands for Versatile Encrypted Inference Library, and at its base we have fully homomorphic encryptions. Queries, they include sensitive data, they include data about new products, they include data about customers, and they include other data. And sometimes the confidentiality of the query itself, it contains more or more sensitive information more than a database query, or actually more than a database content. Query leakage can reveal more than the query itself. And then in most cases, we will be at violations of regulatory and compliance risks. What fully homomorphic encryption enables, one, it enables computation over encrypted data. So instead of the query going into plain text and its content being exposed to the cloud or to the hyperscaler, the data remains encrypted and the inference of the data remains encrypted, the result is generated, and then it is returned encrypted over the user and over whoever sent the query. FHE-based operations do not require iteration between untrusted parties in order to perform the computations. It's a one-one with the server, and it is quantum safe, protecting inference against store now, decrypt later, and all the future quantum threats. You may ask, okay, FHE has been there for a while. It is computationally expensive. And really what excites me most about this technology that we are doing today is despite all the computational overhead of FHE, with the algorithmic improvements and with the usage of hardware accelerators, it becomes something that can be usable and that can be deployable. And this is where we have developed a library that we can make available for medical applications. We have developed it in the form of an SDK, and it has been used by our clients for skin cancer detection and then for other type of medical analysis. Moving on into the training part, because really inference is half of the equation, or it is part of the equation, and this is where we bring in the concept of private federated learning, and this is where we look into privacy when it comes to the training phase. We have multiple issues today. There is one, the fact that whether we're talking about healthcare, whether we're talking about finance, whether we're talking about governments, that all of them sit today on very valuable information. Because of the sensitivities, because of local and international privacy law, this information being siloed in environments and cannot be shared, we are losing a lot on the combined and the common intelligence. Privacy regulations, as I mentioned, they put limitations on the sharing of data. And then even if you say, okay, we can use federated learning, it still requires trusting the aggregation server, and then which means that if you have a malicious or if you have a conscientious server, the reconstruction of the private training and reconstruction of the aggregated model can be compromised. And this is where PetalGuard comes into the equation in order to solve the reliance on this trusted aggregated server. It tackles the issue of data extraction and conventional federated learning. We, unlike differential privacy, which still lacks when it comes to local updates and yielding low accuracies, and then it also tackles the issues of data extraction in the usual federated learning that we know about. And the way we do it, and I think we heard about multi-party computation earlier during the day, Battleguard combines federated learning and multi-party computation, one in order to perform decentralized aggregation, where locally trained models are never sent to a central aggregator. However, aggregations run over random shares that are computed and then they are tackled through MPC protocols. We have zero data exposure. We have end-to-end cryptographic guarantees, no accuracy loss. We go through multiple iterations of this federated learning through the aggregators and through the final aggregator, and it is modular and scalable. What I'm talking about is actually something that's not theoretical. I'm not talking about university research. It's something that's deployable. Federated learning is available through the AWS marketplace and directly through us being deployed with clients. And we are collaborating with Opaque, and we are deploying it with our post-quantum cryptography in order to provide, through multi-party computation and information theoretic security. All the communication are protected using post-quantum crypto, leveraging the cryptographic libraries that we have developed in TII. And then finally, we have Prisme, because AI authentication, identity management, as we know it today in the public key infrastructure, is something that cannot deal with the ephemeral nature of agents and something that cannot allow us this authentication and the identity management of agents themselves. Without going to the problems themselves, I think we are all very well aware of them, is one, agents are of ephemeral nature. There is really no stable identity. Without this verified identity that is associated with agents, a malicious service can impersonate a trusted agent, let alone all the rights that an agent, all the root access that an agent can have over our platform, and then standards are fragmented. And this is where our agents' identity and access management solution comes in, which is Prisme. It unifies all the standards that we know of today, whether it is PIFE, whether it is MCP, whether it is A2A, and provide us with a way for every agent to have an identity, every process and every transaction to be auditable and to be attested for, and then this is how we establish trust in the into the agents and the agentic processes that are running into our platform. We are complemented, Prisme, and ironically will almost have the same name with a platform that is called Agents Guard, and it is really a control plane security that is running, putting the policies, putting the autonomy budget for the agents that are running on our platform. I went fast through these technologies. Our vision for the future is for agentic platforms to have these three components: to provide private training, to provide private inference, and for every agent to be attested for and to be authenticated using its identity. We see this as a whole ecosystem of trust. I do believe that the future of AI is not about who's going to build the largest model. It's really about us as scientists and technologists to develop this trust ecosystem where we can have a trusted execution of those agents on our machines. So the future of AI will be built on trust. And this trust should not only be in policies, should not be in governance frameworks. It should really be built on cryptographic guarantees. With this, I end. Thank you very much for listening to me, for giving me the opportunity to show you very briefly what we are doing at the Technology Innovation Institute. And I'm happy to have further discussions with you. Thank you.